Okay, at this time we're going to be doing our gas heating diagnostic module number 1, and this is a recorded session. So by all means, please keep that in mind as we move forward with the recorded sessions, that if you are participating, you will be recorded during our normal training session or during participation. So welcome to the program today. Today we're going to be going over the Johnson Controls single-stage and two-stage gas furnaces, and some of the key topics that we will be talking about today are as follows. We're going to look at the vestibule layout for 80% as well as 95% furnaces. We're going to be talking about single-stage ECM motor control board layout and connections, two-stage ECM control board layout, and 24-volt connections. Now remember, on some products, they are communicating capable. However, on the single-stage ECM and the two-stage ECM control boards, they will be 24-volt only connection. So as we take a look at our first slide right here, we see this is our 80% vestibule layout. And at this time, we're going to actually look at the components as if you were to take the service panel off. Just imagine that for a minute or two. You take the service panel off, and then you're going to be looking at just like you see in the picture right here. So go ahead and take your handouts or your workbook and follow along. And we're going to encourage that you keep lots of good notes when it comes to the vestibule layout and the other components on the furnaces moving forward. So the first thing we're going to notice in the upper right hand corner, we have a vent connection. You'll notice this vent connection is a metal vent connection, and that's correct for an 80% furnace. You will have to use the appropriate venting material for a metal vent. The induced blower housing, this is where the induced draft blower, the housing itself is also made of metal, and then mounted right on the induced draft blower housing is our pressure switch. Now remember, team, this pressure switch has to be open electrically during an initial call for heat. And we'll talk a little bit more about that when we get into sequence of operation. The hot surface igniter sits behind the gas valve. And then we see in our example here, it looks like we have a single stage gas valve. And this gas valve, remember, it does have an on-off switch on there, so be sure that the switch is in the on position. Can't tell you the number of service calls I've had where the technician is called in with a problem with the gas valve and he had forgot to turn it on. So be sure that the switch is in the ON position, please. Then we have our manifold assembly where we feed the gas to our manifold. And then we have our burner assembly, and please notice those burners are in-shot burners. This is very standard in the industry, and we feature in-shot burners on all of our furnaces. Near the burner assembly, you'll find a rollout switch. Now, we mentioned switches in our PowerPoint here because based on the size of the furnace, you may have one or more rollout switches, typically one or two based on the size of the furnace. You'll also notice that the rollout switch has a manual reset. This is a manual reset safety device. The flame sensor is on the other side of the burner assembly opposite of the hot surface igniter. And you'll notice it has a single purple wire going to it. That's the easiest way to identify the flame sensor. It has a single purple wire going to it. There's our line voltage connection where we bring in our 120 volt line voltage connection to hook up to the furnace. And right near that high voltage connection spot we just talked about is our primary or the high temperature limit. Now please note that this high temperature limit is a automatic reset. And the main cause for that high temperature limit to open or to be cycling is poor airflow. Poor airflow is the #1 cause. So want to make sure that if you have a 4 flash code indicating a high temperature limit is opening up, that the #1 thing a technician should check is the air filter. And then of course fan speed and duct work and so on go hand in hand with that as well. But the #1 cause for a high temperature limit to open is inadequate airflow. Okay, at this time, let's take a look at our 95% vestibule layout. We see that we have our line voltage connection, and then we have a 4-way collector box. Now, this is a Johnson Controls exclusive. It's a 4-way collector box, and what it is, it's an internal trapping and drain system. So unlike our competitors where you have a lot of complicated drains and parts and so on, and traps and vertical traps and horizontal traps and so on our Champion furnaces, our Champion Johnson Controls furnaces, they have a built-in collector box. And so on our condensing style furnaces, our 95% and higher high efficiency furnaces, that 4-way collector box allows internal trapping to the furnace, so you just have a simple single drain line coming out. You don't have a bunch of complicated parts or traps. So they're very, very easy to install and configure, and it's a real bonus for the Champion lineup of our furnaces to be able to have that for ease of installability and ease of serviceability. There's our block drain switch towards the bottom of the vestibule assembly. And right next to it or near it is going to be our combustion air pressure switch, our safety switch to prove venting. There's our combustion air inlet. And it should be noted that all of our furnaces, including our 95% plus furnaces, are all 4-way convertible. So you have combustion air at the top, or you can have combustion air coming in either side of the vestibule assembly. There's our rollout switch or switches. Based on the size of the furnace, you may have more than one rollout switch. And there's our burners, again, in-shot burners. There's the igniter that sits behind the gas valve, just like before. And there's our gas valve. In this example, it looks like we have a single-stage furnace. Now remember, TAME, you can have a single-stage or a 2-stage or even a modulating furnace, based on the product. There's a single purple wire again on the flame sensor. There's our primary or our high temperature limit. Again, that's automatic reset. And remember, team, the number one cause for a high temperature cutout is going to be inadequate airflow. Here's a neat feature we have. We call it a rain gutter on our vent connection. That rain gutter feature allows water to collect in a rain gutter and then run it down the drain instead of going into the induced draft blower. So that's a pretty neat feature. That rain gutter feature actually prevents or greatly reduces the amount of water that can get back into the induced draft blower by catching it as it comes down the exhaust pipe. There's the induced draft blower. Now we notice on our 95 plus furnaces that's going to be a high temperature composite material. We noticed on the previous slide where we had our 80% furnace, that was all metal. And so this is going to be a plastic or a high temperature composite material on the 95 plus furnaces. And look again, one more time, just a simple drain line goes out of the furnace instead of a bunch of complicated traps. So again, one of the real nice features about the Champion furnace is the fact we have on our 95 plus furnaces, we have this simple drain line and we don't have a bunch of complicated parts or traps that we have to deal with. Okay, at this time, let's go ahead and look at our single stage board layout. An example would be a TM8 or 9E, a TM8 or 9E control board. And please follow along in your handout as we talk about these key components. We're going to talk about low voltage wiring and all the inputs and outputs on this board. Now this is going to be a universal statement for all of our control board layout sessions. We've removed all the harnessing for the furnace. From the furnace to the control board, and what we mean by that is this: when a contractor goes in to take a look at the furnace, a lot of this stuff's already harnessed up. He doesn't have to worry about harnessing it. We've removed all the harnesses in the picture today, in the pictures, for training purposes. So please keep that in mind, that what we're learning today are just inputs and outputs on the board. And normally there would be a lot of wires on this board, but we've removed all those wires for the photo, for training purposes. But again, we're going to cover all the inputs and the outputs on the board. So as you refer to your handout or your workbook, please follow along as we talk about all of the 24 volt inputs and the jumper selections and so on this single stage TM8E/9E control board. So starting in the left hand corner, we see that Y1 is our first stage cooling call. And so when our thermostat calls for first stage cooling, this board actually has the capability of a 2-stage cooling capability, even though it's a single stage heating board. So Y1 is our first stage cooling call from the thermostat. Y2 is our second stage cooling call from the thermostat. W is our heating call from the thermostat to tell the board it's time to go into the heating mode. R is 24 volt hot. That 24 volt hot goes up to the thermostat and powers all the thermostat function, as well as allows the thermostat to switch and to power up the rest of the 24 volt system. So 24 volt hot on the control board is marked with an R terminal. The next terminal we're going to talk about is G. That's our fan on call. So when the thermostat calls for fan operation, for instance, in the cooling mode, it will energize the G wire or the G terminal, and it'll bring the fan on. And then we have C for 24 volt common. Now above the low voltage terminal strip, you're going to notice there's some jumpers. Let's talk about those jumpers at this time. The first one we're going to talk about is our continuous fan on speed selection. And it should be noted that this is a very unique feature about the Champion Johnson Controls furnace control, in the fact that we're going to give you some options of what speed you want the fan to run on if the homeowner goes to the thermostat subbase assembly and selects fan on. And so that jumper allows that. You'll notice that we have high cool, we have heating mode, low cool, or just G. And G, again, will be selected by determining our 24 volt input to the board. So this gives us some nice options to allow a continuous fan operation, because a lot of times homeowners like to run the fan all the time, but they don't want it running on full cooling speed or high speed. So this jumper allows a continuous fan on speed selection other than just high speed cooling. Right above that is our blower, our heating blower off delay selection. We normally set that between 100 and 120 seconds from the factory. In our example, we see that our field selectable options are 60, 90, 120, and 180 seconds. And we normally typically set those between 100 to 120 based on the board, if that's one of the jumper selections, if 100 seconds is the jumper selection. But the main thing is the technician can field select how long the fan runs after the call for heat goes away. That's what this is. This is a heating blower off delay selection. So when the call for heat goes away, the thermostat is satisfied in the heating mode. In other words, the fan continues to run a certain amount of time. That jumper allows you to field select how long the fan runs after the call for heat goes away. Right above that is the last error button. That last error button allows you to retrieve flash codes. And it should be noted that the control board will remember the last 5 errors. If it has 5 errors on the board or faults on the board, it will remember the last 5. If there's more than 5, it just kind of rolls off on the end. It just remembers the last 5 errors on the board. Now it should be noted, if you hold that last error button down for about 10 to 15 seconds, it'll reset the memory back to 0. Or if you depress it, you can push it and you can start retrieving the last 5 errors as well. So the last error button is a convenient way for the technician to find out what's going on with the board, if it's had some previous errors, and then to reset the error memory if so desired. As we move around the board, we have a status LED. That status LED will allow us to retrieve flash codes. And we'll talk about flash codes a little bit later on in the program today. But the LED flash codes will tell us what's going on with the board. That LED, we see there's kind of a milky white right now, or an off color. But what it is, it'll actually flash amber or yellow. It'll flash green, or it will flash red, based on the flash code that we're looking at. So we'll talk about flash codes a little bit more in the program a little later on. As we move around the board, we see we have some 24 volt motor connections. Those motor connections are PARC, which is just an unused terminal. If you have an unused terminal, you can just put it on there. It's just a blank terminal. G would be fan output, and then 24 volt common. Now remember, team, an ECM type of motor, which these are high efficiency motors on here. That E at the end of the model number, that TM8 or TM9E, means high efficiency motor. So these high efficiency motors have line voltage power to them all the time. And then we're going to command that motor with 24 volt inputs. So these 24 volt motor connections you see up here are part of that 24 volt control scheme. As we move around to the side of the board, we see that we've got some blower speed tap selections for low cool speed, high cool speed, and heating speed. Again, these are 24 volt outputs to command the motor what to do. Below that, we have a 120 volt electronic air cleaner terminal. That EAC air cleaner terminal will be energized anytime the fan is running. It allows a 120 volt output from the board to energize an electronic air cleaner anytime the fan is running, if it's so desired. That L1 is a 120 volt input to the board to power up the line voltage or the 120 volt devices, for instance, like the transformer and the motor itself. Remember, we commented that the motor itself is going to have power to it all the time, and so the power coming into the board to power up the 120 volt components will come in on the L1. The XFMR is 120 volt output to the transformer to power the transformer up. Where it says line, that's a 120 volt line to power up the motor. So again, the motor, the ECM motor, is powered up all the time, and that 120 volt from the line terminal will be that hot wire, if you will, that 120 volt line voltage power going to the motor all the time. Right below the line terminal, you'll see there's a HUME input, and that HUME is actually a terminal that allows the control board to power up a humidifier if it's so desired. Again, it's a 120 volt humidifier terminal. One of the things I really like about the Champion furnaces is we do a lot of things on the board. You'll notice you don't have to have a lot of extra relays or controls or those types of things because a lot of that's built in on the board. So basically we have a transformer output, we have a humidifier output, we have an electronic air cleaner output, and that's all built in on the board. So we don't have to have special accessories or special things or special controls, for those components. We can actually power them up right off the board, and that's really nice because a lot of manufacturers, a lot of our competitors, they require you to have a lot of accessory items, but we like to build a lot of that on the board whenever possible. So below that we have 120 volt neutral terminals. Again, all these neutral terminals are tied together, and if you were to look at this all wired into the furnace, that would be where all your white wires are hooked up. As we come around the bottom of the board, we have an output harness to the hot surface igniter and the inducer fan motor. Again, this is all harnessed in from the factory. Right next to that, we have a flame current pad. Now this is a really nice feature on our Champion furnaces. And so what this does, this allows the technician to use a voltmeter to read his flame current. Now it used to be in the old days, so to speak, we used to have a special flame current meter. Well, you don't need that anymore with our Champion Johnson Controls furnaces because this flame current pad, if you will, is built right in on the control board. And so all he has to do to read flame current is to take his voltmeter and go to DC volts, and as it turns out, 1 volt DC on the flame current pad right there between those two terminals that you just take your meter leads and put on those little silver terminals. 1 volt DC is equal to 1 microamp DC. Now this is a very important skill that every technician needs, and he should be testing flame current every year. Because if the flame current gets low on the furnace, you're not going to have reliable operation. Now please write this down and remember it. Typical flame current on these furnaces, if everything is working well, in other words, if the flame sensor is clean and we have good grounding on the furnace, and by the way, grounding is the #1 cause of low flame current. So we want to make sure you have a good solid ground on the furnace. But typical flame current should run about 3.5 to 4. But if we have a flame current that drops below 1.5 microamp DC, it'll start generating an amber flash code telling us that we have low flame current. And again, we'll talk more about that later when we get into flash code diagnostics. But just remember, 3.5 to 4 is a normal flame current. Right next to the flame current pad, we have a 3 amp fuse for 24 volt onboard protection. And then next to that, we have a 12-pin harness. And this is where all of our 24 volt inputs and outputs are going to come into the board, from a control standpoint. To give an example, our gas valve and our pressure switches and our safety circuits will all harness in on that 12-pin 24 volt input output harness. Okay, so that concludes the single stage control board layout for a TM9 or TM8E control board. And if I could please have your attention, we'll go ahead and continue into our program as we take a look at some other control boards at this time. The next board we're going to talk about is a 2-stage control board layout, and an example would be a TM8 or TM9Y. Now it should be noted this is a 2-stage heat, 2-stage cooling capable board. And again, because it's a TM9Y or TM8Y, it uses a high efficiency blower motor. Very, very nice furnace. And this furnace gives you two-stage heating, two-stage cooling capability. So if you'll take your handout or your workbook, and please follow along as we go across the picture and we talk about all the inputs and the outputs on the two-stage TM9Y, TM8Y board. So starting in the upper left-hand portion of the board, let's talk about our low voltage wiring like we did before. So going up to the thermostat, we're going to have Y1 will be our first stage cooling call. Y2 will be our second stage cooling call. W1 will be our first stage heating call. Because remember, two-stage furnace, we recommend a two-stage thermostat, a two-stage heating thermostat as well. Now it should be noted that if we do not have a two-stage heating thermostat, or if we don't have enough wires behind the wall, we can actually get some really nice staging function with this control board. Again, one of the things I really like about our control boards is we can give you some staging function even on a single stage thermostat, and we'll discuss that in a minute or two. So W1 is our first stage heating call. W2 is our second stage heating call. R is our 24 volt hot, just like we had before. G is our fan on call, very conventional. And C is our 24 volt common. Now as we move around the board, let's go ahead and talk about some of the key features of this board as well. Our last arrow button is going to operate just like we had before on our previous slide and our previous single stage board. You can depress that last arrow button to retrieve flash codes off the board. If you hold that button down about 10 to 15 seconds, it will also clear the memory. Right next to the last arrow button is a status LED to retrieve flash codes. And again, this is a tricolor LED. It'll flash either yellow or amber. It'll flash red or it'll flash green based on the flash code that we're observing. As we move around the board, we see we have a continuous on-fan speed selection. And again, this is a really nice feature because if the homeowner goes to fan on the thermostat sub-base assembly, these dip switches will allow us to select how fast the fan runs if they go to a fan on or continuous fan operation. Right next to the continuous fan dip switches, we're going to have some for blower heating off delay. And again, if you kind of look at the screen a little bit and also look at your handout, you'll see that there's different options. For instance, if both of those dip switches are in the up position, it'll give you 60 seconds of heating off delay. If both switches are down, it's 180 seconds and so on. So based on where those dip switches are actually located or where they're positioned will determine how long the fan will continue to run after the call for heat goes away. So that's our heating off delay function. The next set of dip switches are heating staging if a single stage thermostat is used. Now this is really important. Sometimes contractors are just stuck with a single stage thermostat. Sometimes the homeowner doesn't want to change the thermostat, or maybe behind the thermostat, behind the wall, there's not enough wires. And so we can give you some really nice staging if you're stuck with a single stage thermostat by these dip switches. You'll notice that if both of those dip switches are in the up position, it's off and we've disabled that function. If the dip switches are both down, what will happen is if you get a call for heat, what will happen is 20 minutes later it will go into second stage to finish the call. And then there's also another function called 10. That's 10 minutes, so it's a time function. If you have it in the 10 position, what will happen is if you get a call for heat from the thermostat, if the thermostat hasn't satisfied in 10 minutes, it'll go ahead and put the furnace into second stage. Now remember, team, this is strictly if you're stuck with a single stage thermostat. The staging function becomes really nice. So again, the 10 function, if you have those dip switches set on 10 and you get a call for heat from the thermostat on a single stage thermostat on that W/W1 terminal, it'll then run the furnace for 10 minutes, and then after 10 minutes it'll go to second stage heat to finish the call. Now the third function, and this is some really intelligent function, is called auto, A-U-T-O. So if one dip switch is down, the other dip switch is up. As you take a look at the graphic or the screen, you'll see that the auto function, the dip switch on the left is down, the dip switch on the right is up. You see the little arrows where it says auto. If it's in the auto position, what the board will do, it'll make intelligent decisions on staging. Now this is with, again, if you're stuck with a single stage thermostat. So in the auto position, what happens is as the furnace comes on, the control board starts monitoring thermostat activity. In other words, how long does it take for the thermostat to satisfy on first stage? And then based on some intelligence that's programmed in on the board, it starts making intelligent decisions on when to bring in second stage. So I recommend put it in the auto position, because at that point you're allowing the board to optimize operation and comfort even if you're stuck with a single stage thermostat. Now remember, team, the best function you're ever going to get is with a two-stage thermostat. And I recommend that. If you've got a two-stage furnace, make sure you use a two-stage thermostat. But we also know that sometimes you're just stuck with a single stage thermostat, or you don't have enough wires behind the wall. Under those circumstances, our Champion furnaces give you some staging function with our staging selection there with our two dip switches. Again, if those dip switches are off, you don't get any staging with a single stage thermostat. But you would with a two-stage thermostat. If they're both off, you still will get staging with a two-stage thermostat. But if you're stuck with a single stage thermostat and those switches are off, you get no staging function. It'll never get out of first stage. In the 10 position, it's 10 minutes between first and second stage. In the 20 position, it's 20 minutes between first and second stage. That's a time function. And then in the auto function, which I recommend, what will happen is in the auto position, the board will make intelligent decisions on when to stage the furnace based on thermostat activity and time. So good. As we move around the board, please keep in mind that staging function should be in the proper position if you're stuck with a single stage thermostat. So as we come around the board, our next function we're going to look at is our blower speed tap selections. You'll notice there's a low heat and a high heat, low cool and high cool, and that fits with two-stage heating and two-stage cooling equipment. So by all means, select those proper speed taps based on your ductwork when you commission the furnace. As we move around, we have a 120 volt EAC terminal. That's for an electronic air cleaner. We put a little red ball on there just to remind everybody it's 120 volt. That CIRC, or that circ terminal, that's your 120 volt that feeds the blower motor all the time. Because remember, an ECM motor, high efficiency motor, has power to it all the time, and then we command it with 24 volt inputs. L1 is where we bring in the 120 volt to power up those components from our power source. XFMR is our terminal to power up the transformer. Right below that is a HUME terminal, that 120 volt humidifier. If a humidifier is desired, that will be energized during the heating mode. Right below that is a big bank, or a fairly large bank of neutral terminals. Those neutral terminals, by the way, are all tied together electrically, so you'll notice that your white wires for your 120 volt components, like your transformer and your motor and so on, will all tie into those neutral terminals. At the bottom of the board, we have an output harness to the hot surface igniter and inducer fan motor, and again, that'll all be harnessed in from the factory. We have a 12-pin harness with our 24 volt inputs and outputs, and again, this will be harnessed in from the factory, team. And remember, this is where you're going to find your gas valve will be wired into here, your pressure switches and your safety circuits and so on will be wired in to your 12-pin harness. Now you're going to notice about in the middle, or excuse me, in the lower left-hand side of the board, you're going to have a 3-amp fuse for protection. And again, these come with a 3-amp fuse, but if you look closely on the silk screening, you'll see you can go up to a 5-amp maximum, but they come equipped from the factory with the 3-amp fuse. Now, as you take a look about in the middle of the board on the right-hand side, or close to the right-hand side, you're going to find your flame current pad. Your flame current pad, again, this is a wonderful feature of our Champion furnaces. It allows the technician to check his flame current with just a common voltmeter. He takes his voltmeter and puts it on DC volts, and he's able to read his flame current directly off the board. This is a very, very nice feature. Okay, that concludes the two-stage control board layout for a TM8 and 9Y furnace. And by all means, as you listen to these recordings, go over them over and over again as necessary to really get a good feel about what's going on with the two-stage control board. At this time, by all means, if we were doing a live session, we'd give you a break at this time, a 10-minute break. But because this is a standalone recorded session, we're just going to continue into our next module. So, gas heating module number 2 will be our next module in this first recorded series. So we're going to be doing gas heating diagnostic module 1 and 2 in this session. So again, welcome to the program, or welcome to module number 2. Key topics we're going to be talking about today will be a two-stage variable speed control board, and then we'll do some flashcodes with some interactive practice, or more specifically to give you the opportunity to look those up in your workbook or your handouts. So let's take a look at our two-stage variable speed control board. An example where this board would be found would be in like a TM9 or a TM8V, V for variable speed. Now remember, team, that a variable speed blower is another type of ECM or high efficiency blower. The main difference is it's going to have a control board and some jumpers on there that we can select our airflow instead of having to physically go down and move an airflow tap on the physical motor itself. A variable speed product with a V, a variable speed product, will have a control board like what we're looking at here. And please follow along as we talk about all those components. But again, the variable speed boards will have jumpers on them that we can select airflow, and we'll talk about that in just a little bit. So starting in the left-hand side of our two-stage variable speed control board, again, examples would be like a TM8 or TM9V product. Starting at the left-hand side, we have C for 24-volt common. Again, this is if you're hooking it up 24 volts. Now, it should be noted that the variable speed furnace is also communicating capable. It's communicating capable. And we'll talk about those terminals as well, but you can also hook them up 24 volt. And so just conventional 24 volt hookup, we're going to be using the terminal strip on the left-hand side that we're looking at right now. So C is 24 volt common. G is our fan command from the thermostat for fan operation. So G is for fan. R is 24 volt hot. That's what powers everything up on the 24 volt side. So R will be taken up to the thermostat to power up the thermostat and to provide the control voltage for all the thermostat functions. W1 is first stage heating call. Y/Y2 is second stage cooling call. So this is a two-stage heating, two-stage cooling capable board. Y1 is our first stage cooling call. W2 is our second stage heating call. Well, this board has some unique functions in the fact that it has a dehume terminal. The dehume terminal allows us to have a standalone humidistat hooked up between R and dehume to provide extra dehumidification. What this terminal will do, if we enable it, what it will do is it will slow the fan down to 85% airflow in the cooling mode if it's humid in the house. So we can actually put a humidistat between dehume and R terminal, permanently wire that in, and then if it's humid in the space, what will happen, it'll slow the fan down in the cooling mode to give us extra dehumidification in the cooling mode. It's a very, very nice feature. The O terminal is for a heat pump, and so this board is heat pump compatible. And so if you have a dual fuel system or a hybrid system, also known as a hybrid system, the O terminal tells the board that the unit is in number one is on a heat pump and it's in the cooling mode. Because remember, on our Champion furnaces and our Champion outdoor units, on our heat pumps, the O terminal energizes the reversing valve for cooling mode of operation. As we move around the board, we'll notice the top left-hand corner of the board in our photo, that's our spade terminal for our fuse. I don't know why I don't have a fuse in that one. Apparently in my photo we forgot to put one in. But it is 5 amp maximum fuse. You can read that. We normally ship with a 3 amp fuse, and again up to 5 amp maximum. As we move around the board, we see we have some communication screw terminals. This board is communicating capable with a 4-wire communicating system. If you look closely in the photo, you'll see there's A, B, C, and R terminals, and those are our communicating terminals. Right next to the communicating screw terminals, we have a status LED, and again, it's a 3-color or tricolor LED. It'll flash either yellow, also called amber in the workbook, red, or green based on the fault that's being detected. Next to the status LED, we see we have a last error button, and it has the same function as it did on the previous boards. If you depress it, you can actually start, if you push that, you can start pulling flash codes off the board. It will remember the last 5 flash codes, the last 5 errors, and if you hold that last error button down about 10 to 15 seconds, it'll go ahead and clear that error or clear the memory. If you look closely on the board, just a little bit below and to the right of the last error button, there's a CFM light. This is a unique feature of our variable speed control board in the fact that it will flash 1 time for every 100 CFM that the fan is blowing. So this is a nice little visual check on our variable speed products, because once we set up our airflow, it's kind of nice to know to visually check how fast that fan's blowing and what that fan's doing as far as CFM. And we can do that by visually looking at that little CFM light. It will flash 1 time for every 100 CFM that it's delivering. It'll then pause about 2 seconds and then repeat the flash code, and it will do that indefinitely as long as the fan is running. As we kind of move around the board, we see there are some optional temperature, auxiliary, and float switch terminals that can be utilized if you have a communicating system. Next to that is a 6-pin ECM motor plug. Now remember, team, like we said before, instead of having a physical jumper on the motor that we're going to move in the field, this ECM motor plug actually has some wires that goes down to the variable speed motor, and then we're going to set up our airflow with some jumpers, which we'll talk about in just a little bit. As we move around the board, we see we have some neutral spades and a 6-pin neutral plug. As we come down the side of the board, we see that we've got a 5-pin plug, and it's 120 volt AC for primary on the transformer, as well as hot surface igniter, as well as for the induced draft blower high and low speed. So it's 120 volt AC, 5-pin plug controlling those components that we've just mentioned: transformer, primary, hot surface igniter, and inducer high and low. Right below that 5-pin plug, we have a humidifier output, and it's 120 volts to operate a humidifier in the heating coil. Right below that is an EAC terminal for electronic air cleaning. Now remember, team, anytime you have a G call or a fan operation, you'll energize that EAC terminal for an electronic air cleaner. As we move around towards the bottom of the board, there's our flame current pad. Again, a very, very nice feature on our Champion Johnson Controls furnaces. This is built into the board, so all the technician has to have now to check his flame current is just a very common voltmeter, and he goes to DC volts, and 1 volt DC equals 1 microamp DC flame current. Now remember, team, flame current is very, very important so the furnace can continue operation. It has to be able to sense the flame, and 3.5 to 4 is the typical flame current. And again, if you've got poor grounding, it can start having reduced flame current. And so grounding is the #1 cause. I can't stress that enough. Grounding is the #1 cause of low flame current. So if you have poor grounding, you may have low flame current. There we have our 12-pin plug again with our 24 volt inputs and outputs. And again, this is all harnessed in from the factory. And you'll notice that if you follow those wires out, they go to the gas valve, they go to the pressure switches, they go to the safety circuits, and so on. So it's all harnessed in from the factory on the 12-pin plug. Now we're going to start talking about some airflow jumpers, and it should be stressed, all the information we're going to be talking about will be in the install information that comes with the equipment. So we're going to review it slightly. We'll talk a little bit about it. We'll talk about what the switches do, but actual details as far as their actual position, A, B, C, or D, or the selections that you will make will be specific based on your service information that comes with the equipment. So let's go ahead and review those jumpers at this time. So the first one we're going to talk about is our delay jumper. That delay jumper is to adjust our ramping operation for cooling on delay. So please write that down or make a note. The cooling on delay function will be utilized with that delay jumper A, B, C, or D. And it should be noted that we normally ship it in the A configuration, which is normal. And what that tells us is the fan, it takes about 30 seconds to ramp the fan up, and then it's at full airflow after about 30 seconds. If it's on the B function, which is a humid function, it's going to ramp that fan. It'll run about 1.5 minutes on 50% airflow. Then it'll ramp up to about 85% airflow for another 6 minutes, and then go on up to 100% airflow. And that ramping operation in that humid environment will give us a much colder evaporator. And what that does, it actually wrings extra moisture out. So that's one of the real big features of a variable speed product, is this variable speed blower motor. It allows you to customize the ramping or the on delay for cooling. And what it does, it allows you to really control extra humidity and so on in the space. So that's a really, really nice feature for variable speed. And so you'll set that up for cooling on delay with the delay jumper. The next two jumpers we're going to talk about, adjust, and again in your workbook or your handouts on page number 36, you'll look at the adjust jumper and the cool jumper. I want to stress this: the adjust and the cool jumper work together to set the control board up for the amount of airflow you need based on the size of the outdoor equipment. Let me stress that again: cool and adjust work together to set the airflow up based on the size of the outdoor equipment. Now please write this down or remember this. We always want to set our airflow up in the cooling mode of operation with the cool and adjust jumper for 400 CFM per ton. So if I have a 2-ton unit sitting outside, I need to set my cool and adjust jumper up for 800 total cooling CFM on a 2-ton unit. If it's a 3-ton unit, it'd be 1200 CFM. If it was a 4-ton unit, it would be 1600 CFM, and so on. So we always set the cool and adjust jumper up for 400 CFM per ton of capacity of the outdoor unit. So the cool and the adjust, they work together for cooling airflow. Right below the cooling jumper, we have a heating jumper. And again, please refer to page number 36 in your handout or your workbook. And the heating jumpers are going to allow us to set up our heating airflow whenever we get a W call on the furnace. Any W call on the furnace will generate a heating call, and so we want to be able to set our heating airflow up based on that. As we move around the board some more, we see we have a humidistat for cooling. Remember that dehume terminal that we talked about on the low voltage terminal strip. If we want to utilize that terminal, we're going to put that humidistat jumper in the yes position. If we're not going to utilize that dehume feature, then make sure it sets in the no position. Because if we have it in the yes position, but we don't hook anything up to dehume, it'll reduce the cooling airflow to 85%, and that's the highest airflow you'll ever get percentage-wise. So be sure, if you're not going to use that cooling dehume terminal that we talked about earlier on our low voltage wiring, if you're not going to use dehume, make sure that that humidistat jumper is in the no position. No position is normal if you're not going to use that dehume terminal. That's very, very important, because we can affect our cooling airflow if that jumper is not in the right position. So factory setting is no, and we recommend you double check that during install to make sure it's in the no position if you are not going to use the dehume terminal. Right below that is a heat pump, and again, if this control board or if this furnace is going to be hooked up to a heat pump outside, we need to configure the board so it knows it's on a heat pump. So it's looking for the O terminal for the reversing valve on the heat pump in the cooling mode. So remember, if you don't have a heat pump outside, make sure it's in the no position. If you do have a heat pump outside, make sure it's in the yes position, and that configures the O terminal if we're going to be using a heat pump. Towards the top of that row again, we have a fan speed. This is our continuous fan speed. This allows the technician to set up continuous fan for the homeowner if they want to have continuous fan in the home. For instance, if they have some real nice air filtration products, or if they just like to circulate air in the house all the time, this allows that fan speed to be selected if the homeowner goes to the on position from auto to on the fan on the thermostat subbase assembly. Now on this particular board, it doesn't give you a specific fan speed, but please write this down or make note of this. Low is about 35% cooling airflow. Medium is 50% cooling airflow. And high is 100% cooling airflow. So it's a high, medium, low type of thing. But again, that can be selected by the field technician if they want continuous fan with a G only call to the board. So remember, the thermostat is saying, give me the fan only on the G only call. And how fast the fan runs will be determined by that jumper, high, medium, or low. Now, typically from the factory, we ship it on the low, but it is field selectable to 50% or 100% airflow with that field selection. Below that, we have our blower delay, and again, that's our heating off delay. That's our heating off delay. So the blower delay is different than our fan speed. Remember, the previous jumper we talked about is fan speed is your how fast does the fan run continuous. The blower delay is your heating off delay. And again, this tells us how fast the fan's going to run, or more specifically, how long the fan is going to run after the call for heat is over. So we typically ship that around that 100 to 120, but it is field selectable from 60 to 180 seconds on the product. And then finally, we have a staging jumper. This staging jumper, unlike our previous control board that had an auto function, this does not have an auto function. It's strictly timeout. It's strictly timeout. So if you're stuck with a single stage thermostat, we can still give you some staging with a two-stage variable speed control board that we're looking at here, but it's a strictly timeout, 10, 15, or 20 minutes. And so if you're stuck with a single stage thermostat and the board gets a W1 call, if it hasn't satisfied that call, let's say in 10 minutes, if that staging jumper is set on 10, that means that 10 minutes later, it'll go ahead and automatically go to second stage to finish that thermostat call. Now remember, team, the only time you're going to use that staging jumper is if you're stuck with a single stage thermostat or you don't have enough wires behind the wall, that sort of thing. And so remember, it has to be on a single stage thermostat. It has to be on 10, 15, or 20. Otherwise, you'll never get second stage. Now this is very, very important. We ship that staging jumper in the off position. We ship it in the off position. And so if you keep it in the off position and you have a single stage thermostat hooked up to the board, what will happen is if that staging jumper is in the off position and you get a W1 or a first stage heating call on the board, what will happen is the board will never go out of first stage heating. It'll be stuck in first stage heating, in other words. And so be sure if you're stuck with a single stage thermostat, you put that jumper on something 10, 15, or 20 minutes. Otherwise, you'll never go to second stage. Now, team, as a final note, we always recommend on a two-stage furnace, put a two-stage heating thermostat on there for optimal comfort and function. But if you're stuck with a single-stage thermostat, you can still get some staging capability by utilizing that field selectable jumper called staging. Finally, the last component we have on our board is a model ID plug on the variable speed motor control. You're going to have a model ID plug. It's just a simple wired plug that tells the board what size furnace it's hooked up to. The important thing we have to remember is that on a replacement board, if you sell a replacement board or the contractor installs a replacement board, they want to make sure and take the model ID plug off the old board and snap it onto the new board so that when they power it up the first time, that new board will know what size furnace it's hooked up to. So that model ID plug is important. It has to be installed on the board so the board knows what size furnace it's hooked up to. Okay, so that concludes our control board layout for our furnace products that we're talking about today. And so now, if everyone will please refer to page number 21 in their handout or their workbook. In this portion of the program, we're going to learn about and discuss furnace flash codes. And so please refer to that pages number 21 and 22 for the following. We're going to talk about single stage and two stage control board flash codes. We're going to talk about some of the likely components to check and when to replace the control board. So as we take a look at our single stage control board, this is just a quick little visual cue for everybody. You'll notice that the brown board that we see here is actually a single stage board. And if you see a green colored board, we know that from a visual standpoint, if it's a green colored board, we know that's a two-stage board. So referring to your handouts, pages 21 and 22 in your handout or your workbook, page number 21 is for single stage boards. Page number 22 is for two-stage boards. So automatically we know right now we're looking at a single stage board. So please refer to page number 21 in your workbook or your handouts as we talk about some flash code diagnostics on a single stage board specifically. And so in this first one we see that we have a continuous amber flash. So we have a yellow flash code on this board and it's continuous amber flash. Well, as we take a look at in our page number 21, we see a continuous amber flash indicates low flame current. And so we're going to check some of the following things. Number one is grounding. We mentioned this earlier. We're going to stress it a little bit more right now. Grounding is the number one cause of low flame current. If you have poor grounding, you're not going to have proper flame current. So make sure that your grounding is very, very good from the furnace all the way back to the power panel. So check your grounding. You want to make sure you have a clean flame sensor. A lot of technicians, they've got all different techniques of cleaning the flame sensor. We recommend do not use sandcloth, but instead use something like stainless steel wool or Scotch-Brite to clean that flame sensor. So make sure the flame sensor is clean. If you don't have a clean flame sensor, you won't have good flame current. Check your flame current before and after you clean the flame sensor. So double check that flame current. And again, typical flame current runs between about 3.5 and 4. And low flame current, that amber flash code will be generated at 1.5. So there's quite a range right there, but make sure that if you have a low flame current, check that flame sensor and check that grounding and clean the flame sensor are some things that you can check. Check your gas flow to make sure that the furnace is being fired properly. If you have inadequate gas or you have a low gas pressure, you won't have proper flame, and it can affect the flame sensing. Make sure your sensor is in the proper location. So make sure that your flame sensor is not bent or moved over or shorted to ground. So make sure it's in the proper position in the actual flame itself. Okay, let's look at another flash code. Our next flash code we're going to look at is a steady on LED. So any color LED, if it's on steady, that means that we've actually had a board failure. But we want to check some of the following. We want to recycle the power, because a lot of times what will happen if you have an intermittent voltage surge, or if you have an intermittent power issue from the utility, sometimes the boards, they don't like that. And so if you recycle the power, we notice that I've personally noticed about half the time if you recycle the power, it'll go back to working. Now you're probably going to go back out there and replace the board anyway, but it's worth recycling the power to see if it'll start working again. However, it should be noted that if you have a solid, steady on LED, what that means is it has failed its internal check, its internal electronic check, the board. And so recycle the power. Sometimes you can get it going, but a lot of times it doesn't. About half the time it'll start up again, but about half the time it won't. But anytime you have a steady on LED, that's a replace the board function. So this is the one time that a technician doesn't have to do a huge amount of troubleshooting. Just make sure that he recycles the power to see if the board will come back on. Sometimes it will, but the important thing is with a steady on LED, the board has failed its own internal electronic check. And so be sure and replace that board if you have a steady on LED. Okay, let's take a look at another one. Here we have a green board, so we automatically know it's a two-stage board. So please refer to page number 22 in your handout or your workbook for some two-stage board diagnostics. So we see we have a red LED and it has 13 red flashes. So as you take a look in your workbook, page number 22, we have 13 red flashes on this two-stage board. And so as we dig a little bit deeper, these are some of the things we need to check. We have 13 red flashes. We need to check the following. we see that the high fire switch is open when it should be closed electrically. And so for some reason or another, we're not closing that switch. So we might have a bad switch, but before we condemn that switch, let's dig a little deeper. Let's double check our vent pipe. Let's make sure we have proper venting. Now, if this product has been installed for a couple years, the vent pipe might be sagging, and it could have water in it. And so we could have a trap, a built-in trap, with a sagging pipe. So double check that vent pipe to make sure there's no traps in there. Make sure there's not sagging, and make sure there's no critters outside that have put debris in the vent pipe. So double check that vent pipe to make sure it's nice and clear. Check your vent pressure. Once you eliminate the vent pipe is okay, double check that vent pressure to make sure the furnace is actually pulling the proper vent pressure to close that switch. Now we're going to talk about how to check vent pressure after a little while in some of our next sessions. We'll talk about checking vent pressure, but make sure you check that vent pressure to make sure that the furnace is actually creating the negative pressure necessary to close that vent switch. What we're trying to say is don't automatically condemn a switch until you check these things first. Okay, and let's do another one. This is a single stage board, and this single stage board is the brown board, as we know, so you'll refer to page number 21 again in your workbook or your handouts, page number 21. And in this example, we see we have a slow continuous amber flash, a slow amber flash. And so that slow amber flash tells us that the board, we can check page number 21, but a slow amber flash, it's normal operation. So normal operation gives us a slow yellow or amber flash, but it also tells us that we have a call for heat, and the board has also gone out and double checked its own electronics, so it's passed its internal check. We have a call for heat, and it's operating normally. So a slow amber flash is what it should have when it's working properly. Okay, and then we have, as we take a look at this single stage board again, that's page number 21, and we have a red LED in this example, and it's two red flashes. And so as you take a look at page number 21 for our single stage board again, it's a 2 red flash LED. And let's please check the following. So we have, in this example, we have a pressure switch that's closed. Now, the pressure switch itself might be stuck closed for some reason. If it is, then you replace the switch. However, during diagnostics, sometimes technicians, what they will do is they'll jumper a switch to try to test it. And possibly, they'll try to rewire something, or they may, so double check that wiring to make sure the wiring hasn't been altered, or the technician that was there ahead of you has not rewired something. So double check that wiring, because sometimes technicians use jumpers, and sometimes they'll try to wire around something to bypass it. So double check that wiring. In addition, did someone forget a jumper? As we said a few minutes ago, a technician sometimes will use jumpers for diagnostic purposes, which is okay, but we want to make sure that they don't leave the jumper on there, because what will happen, it will throw this flash code when you go into the heating mode again, because it'll think it's a stuck switch. So if no one forgot a jumper and it's not been rewired and so on, then if the switch is not opening after the call for heat goes away and the furnace shuts down, it should be open electrically. And if it's stuck closed, then at that point, please replace the switch. Okay, that concludes for our sessions 1 and 2, our gas heating sessions 1 and 2 recorded session. And I want to thank everybody profusely. Thank you so much for attending or for listening to the recorded session today. And we'll continue doing recorded sessions for everyone's training convenience as well as everyone's education. But again, I want to thank everyone today for training with us today in our recorded session. Have a great day, and please be safe. Thank you.